Now we go to next section, how to balance the APV contributions and the APV benefits. So we have contributions and the benefit. So APV of contributions, there are three approaches of determining the APV. First, we assume that a continuous present value random variable obtaining an exact expression as an integral. Second assumption is assuming point of incidence occurs at mid-year of any year using midpoint rule. And the third one is developing commutation function, obtain a compact form and use commutation table. So there are basic functions. So we have 4 decrements, withdrawals, death during active service, and the third one is I, stand for the retirement for disability, and the fourth one is retirement from age service. So there are some notation that we have to focus on. So this is QX tau, the probability of decrement due to all causes between age x and x plus 1. So Q tau consists QX for decrement withdrawal plus for decrement death, and the third one for decrement disability, and the final one is the decrement for retirement. Then the mu x tau is the summation of all the decrements, same as the probability of decrement. So Lx tau is the number of participants that still active in service at age x plus 1. So Lx plus 1 tau is Lx tau times Px tau. So Px tau is from x to x plus 1. So Lx 1 tau over Lx tau. So for Kpx tau is from x to x plus k. So in terms of life table, we use Lx plus k tau over Lx tau. Illustrative service table or IST. Assume that first entry age at 30, earliest retirement, which is the notation is alpha, equal to 60, and the compulsory retirement age, the omega, is equal to 71. Therefore, L71 tau is equal to 0 because all the participants are already retired, not active anymore in the service. Then we move back to the contributions part. So how to find the APV for contributions? So there are two patterns of contributions. First, flat rate, where the C is constant throughout the active service. So H is the years of past service, meanwhile T years of future service. So this is future service and this is past service. So X plus H is the valuation age, which is current age. So how to find the APV at X plus H? So we use midpoint rules. So then we get APV at age X plus H for contribution is equal to this one. We use midpoint formula. So the second one is flat percentage of salary. So the C is not flat rate. So same as the flat rate, this is for past service and this is for future service. So the current age is at X plus H. So still we use the midpoint rules, and finally we get the APV for flat percentage of salary is equal to this one, where this one is constant over each year. So let's try example 5. In an employer-sponsored pension plan, the employer contributes 5% of an employee's salary each year, paid continuously until age 65. Find the APV of future contributions made for an employee hired at age 30 at a salary of 24,000 if delta is equal to 0.08 and TP30 tau is equal to E negative 0.02T. And the salary scale function is SY is equal to E 0.04Y. So all the information are given. So this is flat rate, which is C equal to 5%. So we can use this formula. So the APV at age X plus H. So current age is 30. So the upper bound is omega minus X plus H. So X plus H is 30. And then we substitute all the values. So AS is the actual salary at age 30, which is 24,000. And then 0.05 is the contribution rate. And SY, the salary scale function for S30. And this is for S30 plus T. And we got this equation, and we can solve the integration, and finally we get the answer is equal to 17,550.87 cents. So this is the APV for example 5. Now we go to age service retirement benefits. So we want to look at the benefit. Before this, we look at the contributions. So we use the principal plan benefit is normally the annuity for age service retirement. So retirement can occur from alpha to omega. So from the first retirement age possible for alpha until the last age to retire. So X plus H plus T is age at retirement. So benefit is continuous annuity starting at retirement paying at annual rate of RXHT. So RXHT is X for the entry age, H for the past service, and T for the future service. And the APV is equal to this one. So this one denotes the APV at age X plus H plus T of RM1 per year paid continuously by or to X plus H plus T with survival probabilities based on model for retired individuals. And this is TPX plus H tau, MX plus H plus T, R, so R for retirement, is approximately the probability that X plus H retires between T and T plus DT years from now. And then the APV of the age service retirement benefit for an active employee now at status X plus H is less than alpha. So here, which is the employees are still active. The APV of the age service retirement benefit for an active employee now at status X plus H less than alpha. So the APV X plus H is the integration of all this. And then by using the midpoint rules, so finally we get the basic formula for each service retirement benefit is this one. So the factor of KPX plus H tau, QX plus H plus KR is the probability that X plus H will retire during the 1 year period. So variation from plan to plan occur in the definition of RXHT, the annual retirement annual benefit amount. So we will look at mathematically. At time of retirement, HX plus H plus T, participant receive RXHT and continuous at the same rate per year. RXHT is the rate, so the APV is this one. And then how to find the APV at HX plus H? So we integrate all these components, and then using the UDD, we find this one, and then we use midpoint rules, and finally we get the basic formula is this one. So the APV at HX plus H using this formula, the basic formula. So now there are variations in RXHT. So there are 3 variations. First one is function of service but not salary. So this is independent of salary. And second one is function of final salary or the average salary. So it depends on the salary. And the third one is function of average salary over the career of participant. So this is the commutation function. And then we look at the first one, the independent salary. There are 2 types of our independent salary. So full years of service and specified years of service. So now we try example 6. So a pension plan provides a basic benefit of 15 ringgit per month for each year of service. State the formula for the APV of benefit for a participant now age 40, assuming IST to be applied. So what is the assumption of IST? So there are 3 assumptions. The entry age is equal to 30, so X is equal to 30. And the earliest retirement age, the alpha, is equal to 60. And the compulsory retirement age, which is omega, is equal to 71. So now we draw the timeline. So now the individual or the participant is at age 40. So entry age for IST is 30. So we start from 30. So past service is 10 years. And then RXHT. So X is for entry age and H is the past service, 10 years. So K plus half, the T. So between this interval, the retirement will occur. So how to state the formula? So we use this one. So 15 times 12, because 15 per month for each year. So we have 12 months per year. And then we times with the H plus T. And the APV for this case, so B stand for the benefit case. So last time for contribution we put C, and then this is the formula for the APV of benefit for a participant now age 40. So this is how we write down in terms of commutation function. So this is now we look at the dependent of salary. So the first case for dependent salary, where the RXHT is a fixed fraction. So G is the final salary rate. So we use this one. We start with this one and we derive for the APV, and this is for the benefit function. This is for the annuities, and we can write down this term in terms of commutation function, and this is also for the commutation function. So the APV, if we write down in terms of the normal one, is like this, and in terms of commutation function is like this. So second one, B, RHXT is a fixed fraction. However, G of the average salary rate over the last M years. So suppose 3 years, so the minimum. And then so we have 3 years here, 1, 2, and 3. So the retirement will occur between 40 plus K and 40 plus K plus 1. So we use midpoint rule, and we got this one. So from here we can find the average salary rate, where notation is Z. So finally we get the average salary rate is equal to MZX plus H plus K, the average salary rate over the last M years. And second one is the entry and retirement occurs at exact birthday. So the notation a little bit different. So the Z, we have the top on the Z, and this is for the APV formula, and this is when we write down in terms of commutation function. And this the last one, for the case of dependent of salary. So so the rate XHT is a fixed fraction. So G is final average salary of last M years, the number of years of service at retirement. So H plus K plus half is the number of years of service at retirement. So the summary of RXHT for the dependent salary. So we have 3 types, A, B, and C. So this is the notation, and this is the commutation function. So this G is for the average salary, B case, and for C case we use exact birthday. So now we try example 7. So we have to find this one. So the formula for this one is 1/m, and the summation of a scale function start from x plus h plus k minus m until x plus h plus k minus 1. So the equation given to find mzx is this one. Therefore, we can substitute in the formula and using this one is equal to 37.5. Therefore, the total in the bracket is equal to 150. 4 times 37.5, we get 150. And then we find for the last 3 years using this one. This is the original formula and this is the equation given, and we get 38. Therefore, the total inside the bracket is 114. Then we can get as 36. So as 36 is 36. Then we solve for the last 3 years at age 41. Same step as the age 40. So we get as 40 is equal to 40. So then we substitute in the last 4 years average salary at age 40. So we get equal to 38. So we have to play around with the equation given. So let's try example 8. So employers A and B are age 40. So current age is 40, are earning identical salaries. So they have same salary and plan to retire in the year of age between 60 and 61. Find the ratio of their expected 10-year final average salaries if they are subject to the following salary scales. So for A and for B. We have to find the ratio of their expected 10-year final average salaries. So we have to use dependent on salary for B. So 10 is equal to M. So the last 10 years. So we have to use this formula starting from S50 to S60. And then how to find the total amount from S51 to S59. So this is the scale function given for A. So we can use the accumulated values, which is 1 plus I the power of n minus 1 over I. So then we get 16.2917. Therefore, we can substitute in the formula for the middle and we get 1.8127. Now we find for the employee B. So same, we find the middle. So this time we can sum one by one. And finally we get 1.6. After substitute the middle amount here, because the first and the last one we have to divide with 2 according to the equation, and the ratio is equal to 1.13.